If you assemble all of the pieces together that you need for a typical traditional video surveillance system, you get something that looks like this. Let's talk through what each component does. So, first of all, obviously, the camera system has cameras. They come in various forms for different purposes, but traditionally, the camera is simply the device that's capturing the video. They stream video to the camera system's storage servers because cameras need to be able to store the video somewhere, so they contain some sort of storage medium, usually it's hard drives. These are usually known as network video recorders, or NVR for short, or sometimes digital video recorder, DVR for short. But the cameras will typically stream video to the storage servers 24 hours a day, 7 days a week. Then you have the video management system, or VMS for short. The VMS connects to the storage servers and the cameras so that it can bring historical video and live video together into a single viewing portal for the entire system. Now, this system may be integrated with the storage servers, but usually it requires its own standalone server hardware. And then, if the system has any type of analytics functions or features, this requires additional server side software. It may run on the VMS, but again, usually it's going to require separate servers. To view the VMS, you need a system monitoring station, which is typically just a computer with some proprietary software. Sometimes it may require various plugins or codecs to be installed as well. Now, if you want to export video from the monitoring station, there may be certain requirements for the type of media that you can use. For example, some systems require DVDs. Many systems will let you export a digital file, but oftentimes the video needs to be played by the vendor's proprietary video player. Many camera systems will also integrate with access control systems like keypads, badge access panels, biometric access control systems like finger scanners. So those are all of the major components. Although one more important thing to know, while this is running, you have a constant video stream per camera to the system's storage servers for storing historical video. And then another video stream is active per camera when the system monitoring station initiates a live stream. If you have a lot of cameras, that's a lot of network traffic and it requires a very reliable and resilient network. So this type of system does scale, just not very easily or affordably. For example, let's say you have a storage server that supports 15 cameras and you decide you want to add one more camera. Well, you need to buy an entire second storage server to go with it. That's a very expensive 16th camera. Or let's say you just want to open another location and you only need one camera, you need another server, and you need to install, configure, and maintain that server. So our goal with the Cisco Meraki architecture was to remove anything that got in the way of an organization's purpose for owning security cameras. And we found that with this on-premises architecture that's so prevalent today, just about every component adds some level of resistance to getting to that outcome. Now, don't get us wrong, it can get the job done. There's a reason it's been around for so long. However, when you assemble all of these components, you do end up with a surprisingly high level of complexity.